Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to study the relational data model. So far we have studied the conceptual data model. That is, we have studied the entity classes, their attributes and relationship, and how to represent those. So in fact, when we talk about the relational data model, we always create a relational data model from a conceptual data model. So let me start with the concept of conceptual data model. So a conceptual schema or conceptual data model is a map of concepts and their relationships used for database. So in fact the concept is, in conceptual data model we always represent the entity classes, their attributes and relationship between them. So you would have seen that we have studied entity classes, then strong entity class, weak entity class, time dependent data, supertype, subtypes. So in fact that diagram, that enhanced ERD or EERD, is known as conceptual schema or the conceptual data model. So now in fact we will have to convert this conceptual schema or the conceptual data model into a logical data model. So we must also learn that what is the logical data model. First of all, let me show you the conceptual data model that we have studied already in the class. So here we have our conceptual data model, that is student, course, teacher, project and the field. So these are the entity classes, then relationship between them, and then the attribute of each entity class. So in fact this is the conceptual data model, but we cannot represent or we cannot make a database on the basis of this. So we will have to move towards the logical data model. We will have to convert it into another model that will be implementable in any DBMS. So let's start with the logical data model. In fact we will take this diagram. You will take your diagram of your semester project, your own EERD, and then you will convert that EERD into the logical data model. So let's start with it. So what is a logical data model or the logical schema? A logical data model is a model in which we represent the entity classes, attributes and relationship in such a way that those can be implemented in any database management system or DBMS. So that means if I am using Access, if I am using Oracle, if I am using SQL Server or any other DBMS, then I need to convert this conceptual model into some other model that would be the logical data model. So this is a data model that appears from conceptual data model. So that means we will need this ERD or EERD, and then we will convert that model into the logical data model, and that logical data model can be implemented in any DBMS. So it is independent of DBMS. You can create, but it must be when we will study about the relational data model, then we will be dealing with the tables. So any DBMS that uses or that allows us to create the tables, then it will allow us to do the same. So now here it is. Now we have few types of data models: hierarchical, network and relational data model. We have few other, that is object oriented data model and object relational data model, but we will study the hierarchical little bit and network, and then we will move towards the relational data model. So what is the hierarchical database model? In fact it is a data model in which the data are organized into a tree like structure. You can check. We in fact normally, it is obsolete system now, but it was used or it was created by IBM in 1960, and it was also used in the software of Apollo, right? So that means it was a smart model, but now it is obsolete due to the reason that whenever the size of the database or the volume of the database increases and number of entities, their relationships get complex, then normally we cannot use the hierarchical data model, or we can use it but it becomes complex, right? So that is why this is the hierarchical data model, and in fact is a tree like structure. Let me show you. So here in this model we used to keep the entity classes in a hierarchy. So if there was a hierarchy, that means there was a tree like structure. one entity class on the top, then some other branches, and those branches were having the other entity classes, then other entity classes. So in this way there were different hierarchies, and we were supposed to keep our entity classes in these hierarchies. But the issue was, in the hierarchical data model, we were not able to join a child with two parents, right? So that means if this is the subject and teacher is teaching the subject and a student is studying the subject also, then we must attach the student with the subject. But this model, hierarchical data model, it did not allow us, or it was not allowing to connect this child with two parents. So that was the hindrance. So this was the reason that things got complicated. Whenever we had to find out a record, we had to traverse the whole tree. So that was different, and that was little bit complex. So after hierarchical, we went towards another model known as the network data model after the hierarchical, right? And in which we could keep all the entity classes in the form of a network. That is, any entity class was connected with any other entity class as per the requirements. So let me show you the network data model. The network model is a database model conceived as a flexible way of representing objects and their relationship as compared to hierarchical data model. Its distinguishing feature is that the schema viewed as a graph in which object types are nodes and relationship types are arcs is not restricted to being a hierarchy. So that means there was no concept of only one child and one child having one parent. So now here, in the case of network, any entity class can be connected to any other entity class. So here you can see that order entity class is related to the customer as well as the manager and the salesman. So in fact, this is something with the help of which we can understand this is the network diagram in which a child can have more than one parent. But in the form of hierarchical data model, we were not able to do this. So these are the two network model, two data models, and the third one is the relational data model. That is a part of our course, and we will have to study this in detail, and we will make our data model in the relational model, right? So it is a data model in which we store data in relation, or we represent data in relations. So far we have not studied the relations, we have studied the relationship. Relationship is not the relation, because relationship is the association. While what is the relation? A relation is a two-dimensional table having a fixed number of named columns. You can see that this is a table, two dimension. On the y-axis we can see that reg number, name, or x-axis, sorry, reg number, name, class, and address. So here we have fixed number of columns here, right? And then variable number of rows. You can see this: 1 row, 2 row, 3 row. So each row is representing a record, a tuple, or a row, right? So what is a relation? That means our entity class will be converted into a table. So here is a table, that is student table, reg number, name, class, address. So fixed number of named columns. We have 4 attributes in this table, but we can have variable number of records. As soon as you enter some more records in the table, it will be variable number of rows, that is, it will increase. If you delete any record or records, it will decrease. So it will become variable, but columns will not change. So this is how we represent an entity class, or we represent a relation. And the shorthand notation is, we write down the table name, that is student, and in the bracket we write down all the names of the attributes, right? So we had 4 attributes: reg number, name, class, and address, and this underline symbol shows that reg number is the primary key. So again, in the relational model, we represent or keep data in relations, and relation is a table, two-dimensional table. It has few properties, so let's think about those properties. Number one relation or one table cannot have 2 or more columns with the same name. That means if I have here reg number, name, class, address, and I make another column, that is name, I cannot do that, because in one table student we cannot have two columns with the same name. You may say that, sir, this name will contain father's name. Then I will ask you to create another attribute, that is father's name, because the two columns with the same names cannot exist in a table. It is the property of a relation. Then two different relations can have columns with the same name. Another thing, if I have one table here, student table, another one here, the teacher's table. So in the student table, if I have name, I can also have the name field or name column in the table of teacher. So student teacher can have name, as well as the teacher's table can have the name, right? So this is something that two different tables can have the columns with the same name. Then one database cannot have two relations or tables with the same name. Very simple thing. If I have one database file, I cannot have two tables with the same name. Like two tables with the name student cannot appear in my database, in my that particular database, right? Number D, sequence of column is not important. What does that mean? In fact, reg number, name, class, address. So the sequence is not important. That means name can come after class, and class can go at the place of name, or address can come in the first place. But normally, what is the practice? We normally keep the primary key on the left hand side. The first column must be the primary key. It is not some standard or some rules, but in fact this is the convention that we use. So here in the left column we have the primary key, then we go for the second significant column, then third lesser significant column, and then least significant column. And normally we keep the foreign keys in the end. I will teach you in this lecture, inshallah. So now check, sequence of column is not important, but we can manage those in queries or reports. So if my user says that I want to have this data, but in this way, that the right number must come first, then the address, then class, then name. So in the query we can manage, we can change the sequence of the attribute, the columns, but here it is not required. But as I told you, keep the primary key on the leftmost corner, then the significant, then lesser significant or least significant columns. So it will be better approach, and it is a better approach. So sequence of rows is not important. So again we can manage those in queries, but we keep the rows sorted on the basis of primary key. So again, if these are the attributes, so it is not important that it must be sorted on the primary key or on the name or on the class or on the address. If my one user asks me, give me the data sorted on the basis of class, then I will write the query or will design the query in such a way that it will provide the data in class wise order. If some other user says I need the data in name wise, then I will simply say, okay, write or design a query in which you sort the data on the basis of name. But normally what we do, normally we keep this in the form of the columns, in the form of the primary key. We sort them, sorry. So here we have primary key, and we normally keep the records sorted on the basis of primary key. So 1111, then maybe it must have 3333, 5555, and then 9999. But I again repeat, it is not required, it is not standard, but in order to make the searching fast, we keep these, or we keep all these sorted on the basis of primary key. And check, each row in a relation is unique. That means each row is different from the other one. Maybe there is another student, Abdullah, who is studying in class BSCS and who also resides in Rawalpindi. So all these three values are same, but his primary key value will be different, right? So if it is 1111, it will be some other Abdullah sorry, and if we have here 1111, sorry, if we have another Abdullah BScs and Rawalpindi, again one student Abdullah BScs Rawalpindi, another student Abdullah BScs Rawalpindi, but that student cannot have 1111. His reg number or primary key value will be different, so each row will be different from the other row. So these are the few properties of a relational model. We must understand these and we must use these concepts while making a relation. Now let's move towards the steps for logical relational data model. In fact, there are 4 steps: represent entity classes, represent relationship, normalize and denormalize. So let's start with what is representing entity classes or represent entity class. Let's check. In fact, in first step we take that EERD or ERD and we represent or draw one table for each entity class. As we know that the table with those property is known as a relation. So what we do, we consider every entity class of our project and we make one table for that entity class. Now after this, the attributes of that entity class become the columns of that table. So we will make a table and all the attributes of that entity class will become the columns of that table, and entity class name will become the table's name. I will just show you every bit of it, so just wait. So what we do, we take the entity class and we convert it into a table, and now if we have specialization like supertype and subtype, then we create one table for the supertype and as many tables for subtypes as number of the subtypes. If you have 2 subtypes, then you will create 2 tables for the subtypes. If you have 3 subtypes, then you will create 3 tables for the subtypes. So this is how we represent the entity classes, right? So the weak entity class, the strong entity class, every entity class will become a table. So now check. Let me show you again that conceptual data model. In fact, this is the model that we want to convert into the logical data model. So as per the step 1, we have to represent each entity class: student, course, project, teacher and field. So that means I'm going to have 5 tables, 1, 2, 3, 4, 5. And the table student will contain these 4 columns. The course table will contain these 2 columns, and similarly other tables will contain their own columns. So let's check. If I convert this conceptual model into a relational model, then how will it look like? So check. Here we have the student table, reg number, name, class and father name. So check reg number, name, class and father name. And table name I could not write down here, so here we have student, right? So student, and this is the relation. Course, so here you have course code and course title. So check, this table had only 2 attributes. One is the primary key course code and other is the course title. Then again we had the project, PID and P title. So we had another table, project, with PID and P title. And then we have the teachers table, that is teacher ID, teacher name, teacher designation, and the 5th table, that field ID and field name. So you can check what you have done so far. In fact, you have converted each entity class into a table. One is student, second course, then project, teacher and field. So check student, course, project, teacher and field. So we have converted the table, the entity class, into a table, into a relation. But one thing is, now if I ask you that Tetra 1111 Abdullah BScs Abdul Rashid is taking which course or courses, so at this stage you cannot tell me. Maybe here we have 100 courses, maybe here we have 500 students. So what happens? In fact, at this stage you are unable to tell me Abdullah is taking which course. Similarly, if I ask you CS242, that is Introduction to Database System, is being taken, is being registered by how many students? You cannot tell me. In fact, the reason is you can see here we have only represented the entity classes. We have not shown the relationship between them. So now check. We have only represented the tables. We have converted the entity classes into the tables, but we have not shown the relationship between them, one to one, one to many, many to many. So in the next class, inshallah, we will do it. You will have to study the degree of relationship. There is unary, binary and ternary. Get ready for that. And then you will have to you must have some information about one-to-one relationship, one-to-many relationship, and many-to-many relationship, because when we will connect them, when we will make the relationship, when we will perform the second step, represent relationship, then we will need to know that is this the relationship is unary, binary or ternary or n-ary, or what is the type of relationship, one-to-one, one-to-many or many-to-many. So today's homework is, for your semester project for IDS, you have created the ERD or EERD. Now you will have to convert that conceptual data model or conceptual schema, that is your EERD, into the logical data model. So in fact, you will only have to perform the first step, that is you will have to convert your EERD into the tables. No extra step. Inshallah, in the next class we will study the second step, that is how to represent the relationship. So thank you very much. Assalamu alaikum wa rahmatullah.